Okay, so first translation theorem. There are some other properties. First translation theorem. This is something very good. Like you are given a function multiplied with some exponential and you want to find out its Laplace transform. This is going to be what? You have a function and it's multiplied with e raised to at and you are finding its Laplace transform. The Laplace transform of f of t is going to be f of s. Then when this is multiplied with this one, the coefficient of t is a, just subtract that one. So this is just f of s, which is translated a units to the right. It's minus a, it's right. Yes. So this is just a translation. It means translation along the s-axis, a units to the right. Because we know very well if we are doing f of x minus h, it's the translation of the function which is h units to the right, and if it is this, that is h units to the left, and this is upwards and this is downwards.
Multiply with the ratios.
That's the
expansion
or contraction when the value of the factor differs. Okay, so we can apply this property as well in so many conditions. So I think we are not going to do this. Or we can do this. Laplace transform of t power 3 is going to be what? 3 factorial over s power 4. 3 factorial over s power 4, which is 6 over s power 4. So what is the Laplace transform of t cube times e raised to at or e raised to, let's say, 2t? 6
upon s minus 2 whole power 4.
Just
Yes, sir.
this is s minus 2 power 4. And there is another property what we call multiplication by t.
T power.
We can apply the same property on this problem as well. There is multiplication by t. But exponential one is good and easy as compared to the another one. This is what we call the first translation theorem, also called the translation along s-axis. It means the value of the function changes along the axis which is on s. The next idea is, the first thing is that how do we define unit step function? What is the Laplace transform of t power n? There's n factorial over s power. What is the unit step function? Unit means one step, you are going somehow up or down. So the graphical representation is at some fixed a, let's say.
Piecewise function.
It's a piecewise function. No, it's unit step. Yes. That is what we call ceiling function or floor function, or there is another name for that. So it is like 0 from here, but when you reach a, you take one step upwards and now you are doing this. So this is the graph of your function after a, and before a, this is the graph of your function. Sometimes you start from 0 and sometimes you go to negative infinity. So you are coming around 0, when you reach a, you take a step that is just 1 unit going up.
2 units.
Yes, that is a double step function. But unit step function can be converted into any function. For example, you want to take a step which is 2 units above, just multiply unit step function with 2. Multiply unit step function with 3 and so on. So that's easy. So how can I define this? So this is simply denoted with some sort of calligraphic U. I am not writing that thing exactly. So that is equal to 0 and 1. When this is 0, when t is between a and greater than 0, and this is exactly 1 when t is greater than or equal to 8. So this is how we define unit step function. So it is 0 when t is from 0 to a, it means here it is 0, and when exactly after at a or after a it is going to be equal to 1, and it is denoted by this.
So what is the main difference between piecewise function and unit step function?
We can call this piecewise continuous function because this is one piece which is continuous. This is another piece which goes on forever, which is also continuous. We call this, it is piecewise continuous function. Why it is necessary?
Sir, continuous both the
Why this function is necessary? So these type of problems mostly occur in physics and electricity, electromagnetism and so on. Like you have any function, you want that function not to run up to a. It means you have defined or you have input some function in your machine. Till this fixed time a, the function or the machine will not run. Whenever this time approaches,
automatically.
the function or the machine automatically starts running. So that's the idea behind this.
जैसा कि आपके पास जो कैपेसिटर्स रखे हुए हैं,
Capacitors are like electricity, electromagnetism, these are only containing these type of things. So Laplace transform is mostly what you call formulated, invented or discovered because of solving the problems in electricity, in electromagnetism and so on, especially in physics. So what am I doing now? Now you are going to multiply any function with this unit step function. Then what happens? You are multiplying any function with this unit step function. Then what will happen that the value of the function will be 0 when t is between a and 0. After a, this is equal to f of t minus a. It means first the behavior of the function is this. It starts from 0 and it goes on. This is f of t. And what do you do? When you do this translation, then exactly at a, your function starts and it goes on like this. It means you are going to translate your function a units to the right. And what happens before that? It's going to be 0. So this is the main idea behind it. Now you can start your function at 0 as well. So then this u of t minus a will be simply u of t, and before 0 you are going to say that the function is 0. It means towards negative infinity. But mainly when it comes to Laplace transforms, we always start our functions from t equals 0. Because the domain of definition in Laplace transform is integral from 0 to infinity. That's why. Otherwise, when it comes to Fourier transform, we are always interested from minus infinity to plus infinity. Now the question is, what is the Laplace transform of this function? What is the Laplace transform of f of t minus a multiplied by this unit step function? So that is f of s. F of s is simply the Laplace transform of f of t, whatever it is given to you, and it is multiplied by e raised to minus a s. And it can be found easily with the help of the definition. Is it okay? You will see these type of things mostly in differential equations as well. You are given the initial conditions and boundary conditions in this form. And this is also called the translation along t-axis, because this is t-axis and we are going to translate our function. And I think I missed one name. This is called second translation theorem. Second translation theorem.
ऐसा क्या इसमें हम वही काम कर सकते हैं जो आम ग्राफ के साथ कर रहते हैं, लेफ्ट राइट अप डाउन शिफ्टिंग वगैरह?
Yes, but we have to define a function in that way. We are going to define it. This is the definition when we are going to transform a function towards right and towards left, but we can do the same thing as well. But we can do that thing, but this thing is traditional. This thing is what is present in books and literature.
Okay.
And you can do whatever you want, but this is the thing that we must know for the exam point of view. That's why we are going to do this. We discuss, I think, the Laplace transform of derivatives. Now, if we change the idea, that is the derivative of transform. So derivatives of transforms. It means now it is mainly when you have a function when it is multiplied by t power n. When you have a function multiplied by t power n, then its Laplace transform is going to be, you have transform, this is the transform, this should be transform, and you are finding out its derivatives, and it's going to be, I think, nth derivative times minus 1 power. The first thing was, I think, transform of derivative, and this is derivatives of transform. And we can apply this thing on the same problem as well. We have Laplace transform of e power 2t, that is 1 over s minus 2. Now I am going to multiply this thing with t cube. First I was using the first shifting theorem. Now I can apply this property. Now if this function is multiplied with t power cube, then what I need to do? I need to differentiate this 3 times and multiply with minus 1 power. And I will get the same result. I got this result by using another property. Now I am using the property of the derivatives of transform. And you know very well how to do this. This will be minus 1, and first derivative it would be minus 1, then 2, then minus 6. S minus 2 power 3. Is it okay? 3? No. It's 1. It becomes 4. So it's 6 over s minus 2 power. It's okay now. So just differentiate this 3 times and you are done. The problem was when we have sine 2t multiplied by, let's say, t, what to do? Sine 2t multiplied by t.
2 times derivative.
No, one time, but
Once
2 upon s square.
Laplace transform of sine 2t is
2 upon s square.
2 over s square plus 4.
This was very
Just differentiate
yes, sir.
and multiply with minus 1 power 1. Is it okay?
Yes, sir.
The Laplace transform of sine 2t is this. What am I doing? Differentiating and multiplying by minus 1.
Yes.
So what's going to be the answer in this case? So that is minus 2. This power will be down, so that becomes minus 1, and the derivative of s square is 2s, so this is going to be
Yes, sir.
4s over s square plus 4. Is it right? We have Laplace transform of, not quotient rule,
Derivative.
not quotient rule, I have just written this thing in this way, s square plus 4 whole power minus 1, the power comes down 1 minus from the power, and
Okay, sir.
you can apply this thing. So I think it is okay. So this is Laplace transform of t times sine 2t I applied this particular property and I got this result. And it will not take a lot of time because we know very well what is the Laplace transform of sine 2t. But what is this by definition? By definition, this is t sine 2t e power minus st dt from 0 to infinity. Now you can see that I have three functions which are in product. One is an algebraic, another is trigonometric, third is exponential. Their integral is this. Otherwise, I think we can't integrate this. We can't integrate this by using integration by parts because integration by parts needs two functions. But we have three functions here. We can also do something that we can put the value of s. We can put some value of x for this, for which this converges, and then we can see some good results. For example, I am saying s is equal to, let's say 5. Then what happens? Integral 0 to infinity t sine 2t e power minus 5t dt is equal to 5 times 4 25 29 square. This is that. So simply I evaluated this type of integral by using this Laplace transform. Otherwise it is not possible to evaluate this. So we have special functions, gamma function, beta function, Laplace transform, Fourier transform to evaluate these crazy functions or crazy integrals. But even the good thing is in the complex analysis, what we call residue theorem. The main thing is over there, which can solve lots of problems, which these things cannot solve.
Sir, is minus 6 come?
I differentiated this 3 times. This is s minus 2 power minus 1. Okay, I differentiate once, minus 1 down, this becomes minus 2. I differentiate again, minus 2 down, this becomes minus 3. I differentiate third time, minus 3 down, this becomes minus 4. Now this thing becomes minus 6. Minus 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 6, s minus 2 power. It's a derivative, it's multiplied by
Whole power minus 1 also.
this minus 1 comes from this. Minus 1 power 3 minus 1 power n. Okay, this is how we do the property of multiplication by t. Okay, so the next idea is sign. लिखो क्या था?
फोटो को दिएगा
वीडियो पे ही था
फोटो
It's available. So let us define convolution of two functions. Convolution of f of t and let's say g of t. It is written in this way. f star g.
अच्छा सर ये जो छोटा सा क्वेश्चन था डेरिवेटिव ऑफ ट्रांसफॉर्म जो है इसको हम सिंपल वर्ड्स में कैसे मींस इसकी मोटिवेशनल थिंग बता सकते हैं
Motivational thing is that when you have any function multiplied by some powers of t, then to find its Laplace transform you apply this formula. Any function multiplied by some, let's say, positive powers of t, t power 1, t power 2, and even the thing is problematic. The power of t is 1, okay. The power of t is 2, 3, 4, 5, it's okay. Everything is okay. But what if the power of t is a fraction? Then the derivative would be of fractional order.
ओके
But we have not done fractional calculus yet. In our undergraduate courses, there is no any idea like fractional calculus. We know very well. But it is there. Mostly people are working nowadays, and there are maybe thousands of research papers on this idea. That how to define fractional calculus, how to generalize the results.
अच्छा सर और यहाँ तक जो बात समझ में आ रही है या फिर इस प्रोसेस से हमें ये मालूम हो रहा है कि ये सारे फंक्शंस कंटीन्यूअस हो या डिसकंटीन्यूअस पे भी आप अप्लाई कर सकते हैं लैप्लास ट्रांसफॉर्म
Laplace transform, when we define it, we say that the function should be of exponential order. But it might have finite discontinuities. Having finite discontinuity is not a problem. For any integral, finite discontinuity is not a problem.
ओके
Because when I say that I have this function, I am evaluating this area under a curve, no problem. But I have a function like this, then it goes like this. Then the area would be this. I can find out the area below these curves. Unless the function is exploding at a point, that's a problematic situation.
Okay.
Otherwise, if you have finite discontinuities, that's not a problem. For integration, for differentiation, it's a problem. Because you know very well, if you have a function, let's say x square minus 9 divided by x minus 3. You know very well this is a straight line.
Yes.
When you simplify it, this is a straight line. But actually the problem is at 3, which is like not defined. At exactly 3 it is not continuous.
Okay.
So simply at 3 you cannot differentiate. But you can integrate this function over this whole domain. Because finite discontinuity is not a problem. We can do this. Okay, let us come to the point how we define the convolution of two functions. Let's say f of t and g of t. It's very simple idea. So you take f and you take g and you integrate from, let's say, 0 to some fixed t. It starts at 0 and it goes till some fixed t. If t is time domain, it's a domain of the function, you will write t. If x is a domain, you will write x. Now what should be these values, integral values? The dummy variable for integration is, let's say, tau, or you can keep any integral. One function should be evaluated at tau and another function should be evaluated at t minus tau. This is how we define the convolution of two functions. So f of tau and g of t minus tau, an integral from 0 to t. And why this thing is necessary? This thing is very much important when we find out the Laplace transform of convolutions and when we find out the inverse Laplace transform of products. These things are very much important. But aside from Laplace transform, we can also ask, are these things equal? Are these things equal? We can also ask this thing. So these are always equal. You can just change the order of the integration and the problem is okay. There's no any problem. We got this question in our test. There were 4 things. One was this. They were a bit intelligent, but if someone has some good idea, he can deal with the things easily. The another option was this. F convolution G convolution H and F convolution G convolution H.
Sir, you said Laplace is the condition for all functions.
This convolution defined in this way. It is nothing related to Laplace or Fourier.
Condition की तरह नहीं है.
Yes, yes.
ये condition की commutative वाली है. ये हर जगह तो होती function है.
You take any two functions. If you define their convolution in this way, such that this integral converges, then F convolution G should be same as G convolution F, always. And they satisfy this associative T. And I think one thing else that they should satisfy, that is called the distributivity with respect to addition. Like G plus H, this should be F convolution G plus F convolution. You can also verify this thing easily. There is no any problem. The fourth thing is F convolution G is same as, which one is not okay? So this was the correct option. There was problem of time, so I managed to solve this question in this way. Okay, let us not to check these all the things. I know very well this is true. I know this thing. I don't know these two things. If this is true, this must be false. This is the idea behind it. So you can verify these things easily, that why this thing is true and why it is not. Okay, so this is how we define the convolution of two functions. So if we know this thing, we can simply do lots of things. For example, it is not restricted to f convolution g, but you can also ask what is f convolution 1. What is this? Can we find out this thing? So this is simply 0 to t f of tau d tau. G of t minus tau is going to be 1. So you just evaluate this integral. This is f convolution g. 1. For example, if I ask that what is sine 2t convoluted with some constant, then simply it would be sine 2 tau and d tau. Just you integrate, that's your answer. So you can answer lots of questions with the help of this idea. This is not related to our topic, but this is how we define convolution, and there are some properties of convolution. Now the main idea is that we need to discuss that is related to Laplace transforms, that how to find out the Laplace transform of convolution of two functions. For example, Laplace transform of convolution. So Laplace transform of f convoluted with g. So what is that? It is simply take the Laplace transform of first function f of t and take the Laplace transform of another function g of t and just multiply them. So when you apply Laplace transform, the convolution becomes product. So the operation is convolution. After Laplace transform, that becomes the ordinary product, and we can write this thing as f of s times g of s. This is not something very much interesting. Interesting thing is when you find inverse Laplace transform. So when I take this thing on this side, that becomes inverse Laplace transform of f of s times g of s is simply f convolution g. So you have two functions which are given in product. You find their inverse Laplace transform. So you just take the Laplace transform of Laplace inverse of these two and take their convolution. You are done. This is something that is very much interesting. I think we can do one problem as well, but let me see if it is going to be easy, then we are done. Otherwise we are not going to do this. Okay, how we find this? Inverse Laplace transform of 1 over what is this thing? Inverse Laplace transform of 1 over s square minus 1. That is going to be this is going to be sine hyperbolic at. But we can also do this thing with the help of convolution. So let us check that whether answer is going to be same or not. So I can write this thing as 1 over s plus 1 times 1 over s minus 1. This is my f of s and this is my g of s. Now I will find the Laplace inverse of these two separately and I will take their convolution. What is the inverse Laplace transform of the first function? Is it going to be e power t? It's e power t or minus t? Minus t. And this is e power t. Now I am taking their convolution and that's the inverse Laplace transform. How do I take their convolution? You know very well this is going to be integral from 0 to t. The first function is e power minus tau. Okay. The second function is, are these going to be multiplied? Yes, multiplied. E power t minus tau dt. I have to evaluate this integral. Are you okay with this? I have to evaluate this integral. That's going to be the because I have taken f of t, but just I have changed the variable. And g of t is this. I have written g of t minus tau. I know very well this is convolution. Let us evaluate this. And this is going to be tau, I think. So e power t is outside the integral 0 to t. This becomes e power minus tau, e power minus tau, e power minus 2 tau d tau. E power t, the integral is going to be, is this okay? E power t divided by minus 2, upper limit is e power minus 2t and minus 1. Can I simplify this? This is going to be e power minus t minus e power t divided by minus 2. Taking minus common, e power t minus e power minus t divided by 2. And we know very well this is equal to sine hyperbolic t. This is not a t, this is only t. Because the value of a is 1. So this thing is equal to this. So there is no need to apply convolution theorem here, but it was just to verify the things, that whether can we verify the things that are same or not. There is no any other use behind these all the things. Okay, let us go ahead with maybe one or two last things. Laplace transform of periodic functions. So, Laplace transform of periodic functions. So, let's say we have f of t with the period t, and you know very well what is a periodic function and how we define that particular idea. So, t greater than 0 is called the period of a function if f of t plus capital T is same as f of t, and this is for all t. When this is same, we call that function to be periodic. Okay, so how is that? So Laplace transform of that function, Laplace transform of f of t. Now the integral would not be from 0 to infinity, it would be from 0 to some capital T, that is the period, and e power minus st f of t dt. Since this is not the definition of the Laplace transform, but for compensation we will do something, and that something is 1 over 1 minus e power minus st. So this is the formula for the Laplace transform of a function which is periodic. We can prove this thing, but we are not going to do. But we can also verify this thing. So we are doing the verification. The verification is done in this way. We have sin t, its Laplace transform is 1 over s square plus 1. And what is the period of sine? So we know very well this thing. But now we are applying this formula and checking that whether our answer is same or not. So let us do this thing. Now I am applying above formula to find out the Laplace transform of sin t. So what am I going to do? 1 over 1 minus e raised to minus s. What is capital T? 2 pi. 0 to 2 pi e power minus st sin t. That would be lengthy, I think. E power minus st sin t dt, and I need to integrate this by parts twice. So let us not do this. If you give me another function, then we can verify, otherwise this is okay for now. Is a constant function periodic?
ये हम constant सर bounded तो होगा नहीं bounded तो होगा आपके पास है
It's I think constant and period is whatever you define. It depends upon the definition. Constant function is periodic because periodic function means that this is the function and after that it repeats in the same way.
after some time
Repeats in the same way. You have constant function, let's say this. After this it repeats in the same way, repeats in the same way, repeats in the same way. You can define any fixed value a to be a period of this function.
every constant function periodic
Every constant function is periodic. This is the property of periodic function. And your function is, let's say, constant function, let's say phi. Then what is f of t? Phi. What is f of t plus t? Periodic. So in this way, every constant function is periodic.
conversion
Sir?
can converse every periodic function
No. How is it necessary? So every constant function is going to be periodic. Constant functions are very good, they are easy, but sometimes they are a bit tricky. If a function satisfies this property, function is polynomial, we know very well what is a polynomial, and that polynomial satisfies this condition. Is that a line? Is that linear function or quadratic or constant? If that satisfies this property. If a function satisfies this property, that is always constant. That is always constant. Because I define f of x to be constant. Then what should be f of 2x? Constant. No, not 2 times because it's a constant function. What is f of x plus 1? Constant. So put the values. This will be 2c, c plus c, 2c. So that should be constant. This was the question as well.
ये वहाँ भी सोचा सवाल कराया वो जवाब दिमाग से
This was the question as well. So this is easy to check, but what I did, I took this function. Is this constant or linear? Linear. I found these all the values, put in this one and check that what happens. What is f of 2x? 2ax plus b. What is f of x plus 1? It is going to be ax plus a plus b. Alright, up to here. F of x is this, f of 2x is this, f of x plus 1. Just I put x plus 1 here, that becomes ax plus a plus b. Put the values here.
2 multiply this.
So 2 multiply with this. So 2ax plus 2a plus 2b. 1 minute just. So ax plus 2ax plus b plus b. Am I right? I'm just adding these. Now see 2ax 2ax 2b 2b ax equals 2a. Ax equals 2a. It means what? Ax minus 2a equals 0. So ax minus 2 equals 0. It means either a should be 0 or x should be equal to 2. X is a variable, can't be equal to 2. So a should be 0. It means if a is 0,
then it's constant.
so you can verify this thing. That if a function that satisfies this property, that's always constant. Even this is also the property. If f of x and f of x plus 1 is same, if you have a polynomial, it satisfies this property, that's always constant. And you know very well, a constant is a polynomial of degree 0. Degree 0. So what does this tell? This tells that you have f of x you translate it 1 unit to the right or left, the values are still same, that must be a constant. It cannot be a parabola. You have value here and here same, how is it possible? You have a line, you have value here and here same, it's not possible. Unless the line is
Constant.
horizontal, constant. It's a constant function. So we have very basic questions in the test as well, which are very elementary, but there is a very great idea.
This means that यानी अगर का linear आप कोई constant थी नहीं सकी जरूरी नहीं
constant है
ना वहाँ जो linear है constant
Linear can be anything.
linear can be anything
But when it becomes exactly horizontal, it's a constant.
ना linearity है होने कुछ होगा और periodic function तो constant है जितना आप बताओ
Yes,
तो linear करना है
linear.
linear करना है